All right, hello people watching this video. We are actually doing the second half of 2.5, but I'm going to backtrack a little bit so that we can kind of like regroup and everything. Here is the homework assignment if you have not written it down, 4 through 48 by 4s, and then all those extra things, right? Okay. 2.5 is inequalities, meaning not equal, meaning if it's greater than, less than, greater than or equal to, less than or equal to. Shh. These are the symbols that will be used. And you will put them on a number line and you will shade and find those values. Okay? All right, I think this list is already also over there on the board. I see people writing this down, so hold on. Okay? Yes.
What are we doing tomorrow?
Actually, it won't be for some of us.
I know, whatever. I know.
Are you doing what doing?
Blah, don't tell me that. I don't know. I don't know. All right, so interval notation. Let's talk about like where you have a number line. And let's say you have two numbers. You can write this down or you don't have to. Let's say I have -1 here and 4 here. And I have an open circle and a closed circle. And I have something that looks like that. And I want to write that in interval notation. Interval notation, yep.
-1,
and then comma bracket 4.
4 bracket. Okay, the brackets mean equal to, parentheses mean not equal to. Okay, now here's the deal. Let's say I have x is less than 7. How do I write that in interval notation? X is less than 7. I'm just making this crap up off to the side. This isn't anything. I'm just making it up. X is less than 7. How do I write that in interval notation? Okay, so
I know how to do it.
if it's helpful, I would maybe write it as like on a number line first, okay? So 7 is here, open or closed? Open to the left. Okay, now how do I represent that as like a something, comma, something? Yeah, so what's over here? What lives over here? You're close. Negative infinity is on the left, okay? 7 goes here, and then? All parentheses, infinities always have parentheses, and 7 has also a parenthesis because it's an open circle, right? Okay, so when you have stuff that looks like that, I mean that's interval notation. All of these are interval notation. Okay, do not confuse them with an ordered pair. This is not the like ordered pair -1, 4, like 1/4, whatever. That is interval notation, saying x lives in between those two, right? Okay. All right, so we've done some really easy inequalities already, such as like this one, right? And I said do them as two chunks. So you have two inequality symbols here, and I said group this one first. So over on this side, we did 2 is less than or equal to 3x plus 5. We did just that piece. Got an answer, in this case 2 answers, I think. No, just one answer. Just one answer, okay? And then we rewrote it this way, right? Like if you like to have the x on the left side, you can rewrite it. This one, we took this chunk, right? And like did this, the right half. And then we solved for that and we got this as an answer. And then we combined them together on a number line. So if x has to be greater than -1, greater than or equal to -1, it's a closed circle. Less than 6, we have that going on in an interval notation. If I lump both of those answers together, it's -1, 6, bracket paren, right? Okay, something like that. So when you have like multiple things that you're solving for, always put them together on a number line to see what your solution will look like, okay? Now over here we had something going on where we ended up with -3 and 1/5, and they both were closed circles, or excuse me, open circles, so just parens for both, right? From -3 to -1/5, okay? And we did the same thing there. We did this chunk as the left half. It's kind of like doing the two cases, and then the right chunk over here. We solved each one individually and then went from there, okay? Now, did I tell you on this one that you technically could solve this one just all together at the same time? Did I tell you that? Because there is no x's over here and over here, I could technically just solve this all as one. You want me to show you how to do that? It's faster. It's faster. Okay, I'm going to erase all of this stuff. We are trying to get this x in the middle by itself. So I'm going to subtract 3 here, subtract 3 here, subtract 3 here. So this would be 1 is less than -5x, which is less than -3, right?
No, 15.
-6. I mean, blah, 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 blah.
What?
No,
Negative
15.
6.
I can't math. 15. I'm just seeing if you're paying attention, which, I mean, I'm not, but you are. Okay, divide by -5, divide by -5, divide by -5. Now, here's the deal. This would be -1/5, but since we divided by a negative, we have to flip the sign, right? X, flip the sign again, and this would be -3, right? So technically -3 is smaller than -1/5. So if I move that whole thing around, we have -3 is less than x, which is less than -1/5, which is exactly like what this is here, right? Okay. So that you can do as long as you don't have an x here or here. You can solve it that way where you just leave it all as one unit as long as you don't have an x in either side. Does that make sense? It might make it faster and easier. You don't have to do the two cases, right? Okay, because you are doing the two cases, but at the same time, right? Okay, so if you want to do it that way, you can. All right, now, that doesn't work. We haven't done an example 3 yet. That doesn't work when you have stuff where you have like higher powers, okay? So if you just have x's, like this was x to the first power, this was x to the first power, those are nice. Those are easy to solve. But any power that is higher than just x. So like here we have an x squared. Here we have an x to the 4th power. Here we have like x's. Like this would technically be, what power of x would that be if you multiplied them all together? Any ideas?
No, x to the 9th.
Because this is 6 right here, right? It would be x to the 8th power, right? This is 6, this is 1, this is 1. So if you multiply those together, that would be x to the 9th, or x to the 8th power. So there would be 8 x's in there, okay? So if you have higher powers other than those, you have to do something different, okay? So this one, we're going to use a calculator to solve this thing, okay? But I want to put everything on one side. I want to do that first, okay? So we have x to the 4th plus 10x to the 3rd plus 21x squared minus 40x minus 80. Did that work out fine? Is that okay? Yeah? Okay, so I'm going to graph this thing, and you people who are watching this can't see it very well, but I'll graph it, and then I'll draw what it looks like. So if you need to fast forward, if you're watching this video, fast forward. I'm going to go to my fancy y equals, and if you would like to graph it as well, you can. He is x to the 4th plus 10, I gotta scroll down, 10x to the 3rd. Somebody check to make sure I'm typing this in correctly. Plus 21x squared minus 40x. What's the last term?
Plus 80.
Plus 80? Minus 80. Minus 80.
Oh, shoot.
Minus 80. Okay, now I'm going to graph him, and we'll see if we have to, like, zoom out on our table. Yeah, because my graph's not going to show anything. I think I'm way zoomed in. Window. Yeah, I'm really zoomed in. -10 to 10. -10 to 10. All right, graph. All right, how many places is he going to cross? I don't know. So right now he's only crossing 2 places, which is okay. He's x to the 4th power, so he's probably doing a little W down below, right? Do you guys see that? He's like really tall, but he's probably doing a little W down below. So when I graph it, this is what it looks like if you're watching this video. Oh, hold on just a second. I gotta pick up the wrong pen here. Okay, he's doing one of these, and the graph actually looks like this, and he goes all the way down, and I'm guessing he does a little W. It doesn't really matter what he's doing. We want to know where these 2 points are, okay, like we usually do. We're trying to find where that is and where that is, okay? And I'm going to zoom in to find them. Zoom in. I wish it didn't take so long for these to graph. Sometimes it feels like they're just like sketching as slow as possible. All right. Okay, so I see -1.53 is this guy. Okay, we'll go with that. All right. Now I'm going to zoom out.
So all these we have to graph them like this or no?
No, there's some that we can like break down, and you won't have to graph them. I'll show you how to do that. You've done these before. Like if it's a quadratic, you find your critical numbers and you put them on a number line, and then you use your test points. That's what you're going to do. You've done that before in calc, and you hated it.
So like all the bigger power ones, like x to the
all the x to the 4th powers where we don't want to break them down and like find the actual answer individually. That's when we'll graph them. Yeah. Gosh darn it. Okay, now I gotta zoom in. Hold on, this takes just a generous chunk of time here. Enter.
I don't think I'm gonna take. What did we take first one?
1.9. We'll go with that. All right, perfect. There we go. 1.9 ish. Okay.
Yeah, just like the rest of us.
Either you do 2 in one thing or you do it on the remake day.
I'll just do it when somebody.
Okay, so here we go. You ready for this? All right, are you ready for this? This is the confusing part, and it's hard for people to visualize. It's really not that bad, but it's hard for people to visualize, okay? So are you ready for this? We have basically 3 chunks of this number line, right? So like think about the x-axis. I have this chunk right here, which is everything on this side of 1.53, right? I have this chunk right here, which is everything in between these two. And I have this chunk right here, which is everything on this side of 1.9, right? I want to know when it is greater than 0. Do you see that? Where this function is greater than 0. That means above the x-axis, right? So is he going to be above the x-axis here, or here, or here?
Both. The outside one.
The 2 outside ones. You see where these like little tails are going this way, right? They're going out, right? He is below the x-axis in between those 2 numbers. Do you see that? So if we write this in interval notation, right? Okay. How do I represent this chunk right here?
Negative 1. Oh, that chunk.
Negative
1.53.
infinity. Negative infinity is all the way to the left, right?
Yeah.
2, negative 1.53. Oh shoot, should this be a bracket or a parenthesis?
Bracket. Yes, it's a bracket because it's at 0. That's all you want to know.
But look at the original function.
Well, you go
It's
to
not like
Look at the original. It's not an equal to, so it's going to be a paren. Yeah? Okay? And then since we have 2 separate regions, we do union. Have we talked about union before? Union. Okay, so if you 2 separate regions, you just put a union in between them, okay? And then the other one, we said this chunk was the other chunk. Where does that go from?
1.9.
1.9 to infinity. You see how that works? We are above the x-axis on the outsides of those 2. In between those 2, we're below the x-axis, meaning we're less than 0. Do you see how that works? So that's how we use the calculator to do that stuff for us, yeah? Okay. Did we do example 4 together already?
Yeah.
Yes, we did. Okay, so you did a quadratic, and you did maybe the quadratic formula, right?
Yep.
Did you do the quadratic formula? Do you remember the 2 numbers you got with the quadratic? It's like decimals.
Negative 2.35 and
3.5 and 0 point what?
8.6.
0.86. Yeah? Something like that?
5.
8.5. Okay. All right. So when you do the quadratic, you find out that those are 2 numbers after you add and subtract and do all that stuff, right? Okay. We have them on a number line. This is a number that's like greater than just x, right? It's x squared, okay? So here's what we do. We get these 2 things, and these guys are called, I don't know if I said this before, these guys are called your critical numbers, okay? Meaning something is critical at like something is happening at those points that is critical, right? Okay? So what we're wanting to do is we're looking at this region in comparison to this region in comparison to this region, and what we do is we find some test values, okay? So give me a number that is on this left side.
Negative 3.
-3. Give me a number that's in between those 2 numbers.
0.
0. Always choose 0 if you can. Always choose 0, okay? And over here, let's choose like 1, okay? So we're going to plug those points in. If I do -3, right? 2 times -3 squared plus 3 times -3 minus 4. I'm trying to see if that is less than or equal to 0. -3 squared is 9. This becomes 18 minus 9 minus 4.
No.
Is that less than or equal to 0? No, because this is minus 13, so 5. 5 is not less than 0, so I'm going to cross it off, right? Okay? If I plug 0 in, okay? 0 squared is 0. It knocks the 2 out. 0 times 3 knocks that out. Is -4 less than or equal to 0? Yes, this is the region that I want. If I plug 1 in, 1 squared is 1 times 2 is 2 plus 3 minus 4. 2 plus 3 minus 4. Is that less than or equal to 0?
Greater than.
It's greater than 0, so no. Okay? So I want to represent this chunk right here. Okay? How do I represent that middle chunk? My leftmost point is negative 2.35, yeah? My rightmost point is 0.85. And do I do brackets or parens? How do I tell?
No,
Brackets.
brackets.
It's
greater than
equal
negative
to, so I'm going to do brackets. This is the region where it will be less than 0, right? That's how that works. Do you see how this works?
Yes.
If it is an exponent that is higher than just x, you have to do this process. Sorry. Okay. All right, let's do this one here. Okay? This one is actually not as bad as what you think, right? We have to solve for x to find our critical numbers. That's step number 1. I'm not going to solve this thing and find critical numbers because it's x to the 4th power, and that's really ugly. This one we said was x to the 8th power, but this one is not very ugly because he's already broken down. And if he's already broken down, we literally just take these guys and we set them equal to 0, right? So what will this critical number be? Negative 5. This critical number will be 2. Now, he is to the 6th power. What does that mean?
X to the 6 and x.
That just means it's x minus 2 times x minus 2 6 times. But it doesn't matter. I'm just going to have 6 critical numbers that are the value of 2. This has a, if you've ever heard of this before, this has a multiplicity of 6, right? That means the number 2 shows up as an answer 6 times. Whatever. We don't care about that. X equals 8. So we really only have 3 critical numbers, right? 3 critical numbers is what we have. All right, here we go. So I'm going to put them on a number line, and they are in order. Make sure you put them in order. So negative 5, 2, and 8, right? And what we're going to do is we're going to look at our intervals, right? How many intervals do I have to test?
4.
4. If I have 3 critical numbers, I have 4 chunks, right? 1, 2, 3, 4. 4 chunks, yeah? Okay, so on the left side, what would you like to test there? Negative 6, sure. What about negative 5 to 2? 0. Oh, I mean, you could test negative 3, but let's make it easy on ourselves. 0. What between 2 and 8?
3.
3, sure, it doesn't matter, right? And 8 to infinity?
10.
Let's test 10, sure, I don't care. All right, so let's do those. Negative 6, if I plug negative 6 in here. All right, negative 6 plus 5 is a negative 1, right? Negative 6 minus 2 is negative 8. If I take negative 8 to the 6th power, it's going to be a positive number, right? Anything to the 6th power is a positive number, right? Okay? And negative 6 minus 8 is a negative 14, okay? Now, I'm not even looking at the value of these things, okay? Because we're comparing to 0, okay? I don't even look at the value. If I take a negative number times a positive number times a negative number, it's going to be a positive number. Is a positive number less than or equal to 0? No, it's greater than 0, so it doesn't work, right? So we're going to cross him off, okay? We're going to do the same thing again. All right, now we're starting with 0. If I take 0 plus 5, is that a positive number or a negative number? 0 plus 5 is a positive number, okay? 0 minus 2 is a negative 2, and if I take that to the 6th power, that will be positive. It'll be positive whatever, 2 to the 6th power, whatever that is, right? Like a big number, okay? If I take 0 minus 8, it's going to be a negative number, right? Okay, I don't care what these numbers are. I just care about positive and negative. Do you see why that is? Right? What's a positive number times a positive number times a negative number? A negative number. Is a negative number less than or equal to 0? Yes, so I'm going to circle that region, okay? Now we're going to test the number 3. Are you getting the hang of this, kind of? Okay, 3 plus 5 is positive 8. Positive, okay? 3 minus 2 is 1 to the 6th power. FYI, if you haven't figured this out, if you take any number to the 6th power, it's always going to be positive, right? Like a negative number to the 6th power is positive. A positive number to the 6th power is positive. All right. 3 minus 8 is negative. Will this end up being positive or negative? Positive, positive, negative. Negative. It's an odd number of negatives. So is that going to be less than or equal to 0? Yes, it is. Okay. And what about 8 and beyond? Let's try this. 8 and beyond. So we said 10. 10 plus 5 is positive. Okay? 10 minus 2 is 8 to the 6th power is still positive. 10 minus 8 is positive, right? Positive times positive times positive is going to be a positive. Is that less than or equal to 0? No. Okay, so this is my answer. Those two chunks together. How do I represent those two chunks together? I'm going to put it in interval notation. You can do that if you want to, right? I'm going to go -5 to... What?
Okay, so couldn't you use 8 as one of your critical numbers? 8, no.
What?
Could you use 8 as one of your critical numbers or no?
One of your numbers that you're testing?
Yes.
No. You want to use a number that you're not testing. So like 10 and 3 and 0 and -6. Okay? So -5 to what?
8.
8, right? We don't even have to do 2. We can go -5 to 8. Brackets or parens? Brackets, because this guy is a bracket. Do you see that? So I don't care what this thing looks like. I just know that between -5 and 8, he's going to be less than 0, meaning the graph, like if here's -5 and here's 8, right? He is less than 0, so he's doing like some stuff down here, whatever, right? He's below the x-axis. He is less than 0 between those two numbers. And then he's doing something up here, I don't really care, right? But between those two numbers, he is lower than 0. He's less than 0, right? Does that make sense? Okay, and actually really what he's doing, the reason why we had a 2 as a critical number, at 2, he's coming up and he's doing one of these and he's coming up and he's kissing it and then he goes back down and then he comes back up, right? That's what he's doing, right? At 2, he's just coming up and touching, but he still stays below, right? But he's touching that thing, right? Yeah? No? That's what he's doing. No? Don't look at me like I'm stupid.
Don't ever say it's kissing the line.
It's kissing the line. It's just not even going above it. It's kissing the line and then going back down. So that's what's happening, basically, okay? But -5 to 8 is the solution region that we're looking for, yeah? Yeah? Good? Okay? All right. On the back side. Blah, 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 blah. On the back side. How much time do we have?
I've already passed the
It's
calculation.
31 right now, so.
9 minutes.
9 minutes. Oh, we can get this done in 9 minutes.
I think it was like 3. No, I think it was like 8.
I don't know.
You
I don't know.
compare and look at number 40 because it's asking for.
I will here in a second.
Read.
I will here in a second. Okay? All right. Solving a cost inequality. They give me that this is the cost of ordering and storing laser printers. Okay? So this is how much it costs me to order and store them. If the delivery truck can bring at most 450 printers to order, how many printers should be ordered at a time to keep the cost below 1,600? So I want 1,600 to be the cost, and I want this chunk to be less than or equal to 1,600. Do you see how that works? 1,600. This thing, 2x plus 300,000 over x. There he is. Okay? Good? Maybe? Ish? Don't worry about the 450. We'll keep him in the back of your mind. 450 is the most printers that I can fit on a truck. All right. There we go.
I think we draft it.
Okay.
What do you say?
We don't have to. What would you like to do first? I hate fractions.
Multiply by x.
Let's multiply everything by x. So x, you get an x, and you get an x, and everybody gets an x, right? 1,600x greater than or equal to 2x squared plus 300,000. Now what?
Move it all to one side.
Move it all to one side. I'm going to move it over here. I'm going to move the 1,600 over there. So 0 greater than or equal to 2x squared minus 1,600x plus 300,000. Now what?
Complex or no?
It is technically
Divide by
kind
2.
of. Actually, but you can divide by 2. Right? Everything divides by 2. So 0 greater than or equal to x squared minus
800.
800x plus
1,500.
150,000. Okay? Good? Good? All right. Okay. This is going to seem really silly. Hold on. Wait a second. This is going to seem really silly. This is technically a simple trinomial, but we are multiplying. Okay, follow along here. We are multiplying to get this number, but we are adding to get this number, right? Okay, now here's the way that this works if you have zeros on the end. I'm going to try to simplify this as much as possible, right? If you knock off 2 zeros here, you have to knock off 4 zeros here, because 2 zeros, like 100 times 100, makes 1 with 4 zeros, right? Okay, so what can I multiply to get 15, but when I add them, give me -8?
5 and 3.
5 and 3, okay? But it's not 5 and 3. It is
Negative 5, negative 3.
negative 500 and negative 300. Do you see how that works? Right? Okay? Because 500 times 300 is 150,000, but 500 and 300 make 800, right? Do you see how that works? Okay? So that means x equals 500 and x equals 300. Great. Okay. So I have to slap those on my number line because those are called my critical values, right? Okay, so I slap 300 here and I slap 500 here, right? Now, let's talk about other constraints that we have. We know that we can't have less than 0 units, right? Like we can't have a negative number of units sold. So we're not even gonna, we're gonna ignore this over here. We can't have a negative number of units sold. Also, we can't have greater than 450 on a truck, right? So I'm gonna cut it off at 450 here, and I'm gonna say we're not even gonna talk about that. So really, we only have how many critical ranges, like test intervals that we have to test?
300 to 450.
Yeah,
1, 2.
2. We have to test between 0 and 300, and we have to test between 300 and 450, right? So give me a number 0 to 300. 150? I'm gonna do like 100 or 10. 10 or 1? 1? Let's plug 1 in. All right. What about 300 to 450?
400.
Maybe do like 400. I like 400 that has zeros on the end of it. Okay. All right. And we are basically, okay, follow along. Are you ready for this? This is my equation right here, right? I want to know if this chunk is less than or equal to 0. Do you see that? Okay. So if I plug 1 in here, right? If I plug 1 in right here, 1 minus 500 is going to be a negative number. 1 minus 300 is going to be a negative number, okay? If I take a negative times a negative, that is a positive. Is a positive number less than 0? No, so I don't want that to happen, right? Okay? Now, I'm going to go back through and I'm going to plug 400 in, right? I don't want this to happen. 400 minus 500 is negative. 400 minus 300 is positive. A negative times a positive is negative. Is a negative less than or equal to 0? Yes. So I want to haul between 300 and 450 units on this truck because that will make me a profit of, or keep my cost below 1,600 because it costs me to haul those things around, right? To like take them to places. So I would say 300, comma, 450, and they are both in brackets, right? Okay. Does that make sense? Okay. So that's the only reason with the story problem, like you have to like take realistic things into consideration, like you can't have less than 0, or in this case, we can't have more than 450. Okay, so any values higher than just x, like x squared, x to the third, you have to put them on a number line, and then plug in points, or graph it, okay?
Yeah.
Woo!